to transmit power from driver to driven shaft can be done via chain drive. So today's topic of discussion is chain drive in mechanics of machine. Chain drive is a combination of sprockets and chain. In simple mechanism there are two sprockets. One sprocket is the driver sprocket, which is mounted over the driver shaft, and the second sprocket where power has to be transmitted is driven sprocket, and driven sprocket is mounted over the driven shaft. Both these sprockets, the chain is wrapped around them. So by this means the full chain assembly is completed, and then power can be easily transmitted from the driver sprocket to the driven sprocket with the aid of chain. So the important terminologies in chain drive are D1, D2, R1, R2, P, theta, F1, F2, N1, N2. Whereas D1 is the pitch circle diameter of driver sprocket. Here it is. So this is the driver sprocket, and whereas D1 represents the diameter, the pitch circle diameter of driver sprocket. D2 is the pitch circle diameter of driven sprocket. Here's the driven sprocket and the diameter, the pitch circle diameter of driven sprocket D2. R1 is the pitch circle radius of driver sprocket. Here's the R1, which is the half of the pitch circle diameter, and this R1 is named as pitch circle radius of driver sprocket. The R2 is the half of the diameter, the pitch circle diameter of driven sprocket, and named as R2 named as pitch circle radius of driven sprocket. P represents pitch, which is the distance from hinge to hinge. So a single element of the chain, there are two hinges, so center distance to center distance of this hinge hole is represented by pitch P. Theta is the pitch angle. So if we draw a line from the center of sprocket to the center of hinge hole, and then we combine the other center of the sprocket to the hinge hole, which is represented by the pitch. So the angle between two hinge holes to the center of the sprocket is denoted by theta, which is the pitch angle. F1 represents number of teeth of driver sprocket. How many teeth on the driver sprocket can be represented by F1, whereas F2 represents number of teeth on driven sprocket. N1 is the RPM of driver sprocket, and N2 is the RPM of driven sprocket. Very important thing that you have to focus on is this triangle. This triangle is simple, it came from here. So the angle theta, so this whole angle is angle theta. If we divide this half, then the half of angle becomes theta by 2, whereas hinge to hinge distance is represented by P. So a single chain element, this hinge to hinge distance is denoted by P. The whole angle is angle theta, whereas half of this bigger triangle is denoted by theta by 2. And very important thing that you can see here, this length, the length from center to the center of this hinge hole is D, and the length from half of the pitch is denoted by d2 by 2 sine theta, and the whole pitch can be represented by 2 into d2 by 2 sine theta by 2, or in simple d2 sine theta by 2. If you have some question about this triangle or you want more explanation, then please let me know. As I earlier mentioned, that the pitch P is twice of this length, or twice of d2 by 2 sine theta by 2. So here it is. We can cancel this 2 into 2, so we can get pitch P is equal to d2 sine theta by 2, whereas this theta is equivalent to 360 degree divided by number of teeth on the driven sprocket. So if we start angle from here and we take a whole round, so this will be equivalent to 360 degree, and theta will be equal to 360 degree divided by number of teeth on the driven sprocket. If we put this value of theta in the pitch, then we can get pitch P is equal to d2 sine 360 degree divided by 2f2, or if we cancel this 2 with 360 degree, then it left us pitch P is equal to d2 sine 180 divided by f2. A very similar statement here is for the chain drive, and this similar statement is with respect to the belt drive. So number of teeth, the relationship between number of teeth and RPM, it's inversely proportion. So F2, the number of teeth of a driven sprocket divided by number of teeth of driver sprocket, is equivalent to RPM of driver sprocket divided by RPM of driven sprocket. So these are few equations, and we can discuss more on the next slide. The pitch circle radius of both the driver and the driven sprocket can be found out via the formula that has been used in the previous slide, which was the pitch equation. So from the pitch equation, we can easily derive the pitch circle radius of driver sprocket and driven sprocket, which is equivalent to, for example, R1, the pitch circle radius of driver sprocket is equivalent to pitch by 2, P by 2 cosecant 180 divided by F1, whereas pitch circle radius of driven sprocket, this R2, is equivalent to P by 2 cosecant 180 divided by F2. Another very important terminology that we are seeing here is the length of chain. So if we start chain from here and we measure the length all around both the sprockets and it ended here, so how much will be the length of this chain can be easily calculated via this equation, with length of chain is equal to 2x, where x is the center to center distance of driver to driven sprocket, this x. So L is equal to length of chain is equal to 2x plus pi into sum of pitch circle radius of driver sprocket and the driven sprocket, plus we have to subtract the radius of driver sprocket with respect to the driven sprocket and take the square of both divided by 2x. Also, we can easily derive this length of chain. If you want me to derive this length of chain, means that how this equation is came here, then please let me know. A very important thing that we have to sum up here is this terminology. The product of pi into the R1 plus R2 is also equivalent to pitch into F1, the number of teeth of driver sprocket, plus F2, the number of teeth of driven sprocket, divided by 2x. How we can use different equations that we have seen in the previous slide to the real life problem. So here is the problem that we have to solve. So the statement of problem is chain drive is used to transmit power between two shafts. The speed of driver and the driven shafts are 300 rpm and 150 rpm, means the speed of driver shaft is 300 rpm, speed of driven shaft is 150 rpm. The number of teeth of driver sprocket, are 30. The pitch circle diameter of the driven sprocket is 700 mm. So the pitch circle diameter, the D2, is equal to 700 mm. Distance from the center of driver to driven sprocket is 1000 mm. Distance, the center to center distance is 1000 millimeter. We have to find what? Number of teeth of driven sprocket. How many teeth are on the driven sprocket? And we have to find pitch and length of chain drive. So we have to find P, pitch, and length of chain drive. If we start here, then we measure whole length till here. Or we have already have a equation to find the length of chain, so we can use the same. To make the thing simple, I have solved the problem on chain drive in the Excel sheet. You can easily download this Excel sheet and then you can scroll down the given data, required data, and then solution, that what type of formulas I have used in this solution to get the required data. And also I will request you to please verify my result. You can do it on the separate Excel sheet or on the sidewise. Just make this equation, write down this equation and calculation by yourself, and then verify my results. So let's move stepwise. So given data is the speed of driver sprocket, which is represented by N1, it's given 300 rpm. The speed of driven sprocket N2, 150 rpm is given. The pitch circle diameter of driven sprocket D2 is given, which is 700 millimeter or 0.7 meter. The number of teeth of driver sprocket F1 is given, which is 30 teeth, and center to center distance X, which is the center distance of driver sprocket to center distance of driven sprocket, is given, which is 1000 mm or 1 meter. Required data is the pitch circle diameter of driver sprocket is unknown. The number of teeth of driven sprocket F2 is unknown. The pitch angle theta is unknown. Pitch P is unknown, and the length of chain drive L is unknown. To solve this problem, first we have to use a relationship between number of teeth and RPM. So F1 is known, N1 is known, N2 is known. Then we can just side this F2 at one hand, and we can take the other variables to the other hand, and then we can easily calculate the number of teeth of the driven sprocket, which came equal to 60. So number of teeth of driven sprockets are 60. We can verify this result. It's very simple. Like you can see that the speed of driver sprocket is 300, where speed of driven sprocket is 150, which is half of this 300. This means the number of teeth of driven sprocket will be twice of this driver sprocket. So 60 is twice of this 30. So our result is safe and it's okay. The second thing is we have to find the pitch circle radius of driven sprocket, which is the radius is equal to half of the diameter of driven sprocket. So 0.7 divided by 2 is equal to 0.35 meter. The formula for pitch, which is equal to 2 into the radius, pitch circle radius of driven sprocket into sine 180 by f2, and the answer will be 0.049 meter. Whereas length of chain is equal to 2x plus pitch into sum of the number of teeth of driver and driven sprocket divided by 2 plus square of pitch divided by 8x, and then we have to multiply this whole thing with the cosecant of 180 by f1 minus cosecant of 180 by f2 whole square. So the result will be 4.26 meter. So here's the solution. We have got the number of teeth of the driven sprocket, the pitch circle radius of driven sprocket, pitch of sprocket, and the length of chain. So problem is solved.